Hi guys, welcome back. We're going to cover section B and C today as we keep talking about fresh water. Okay, so a little bit of chemistry here. We'll do more of this in 8th grade, but just so you kind of understand what's going on here. So water we know is H2O. That means there's 2 hydrogen atoms for every 1 oxygen atom. Okay, but the way this works is the oxygen is slightly negative and the hydrogens are slightly positive, not totally, but just a little bit, okay? And so if you get another water molecule, it's going to want to kind of stick to that, okay? Because opposites attract. So the positive of the hydrogen is going to kind of be attracted to the negative of the oxygen, okay? That's known as being polar. And we get some unique features of water simply because it's a polar molecule. One of those features is this thing known as capillary action. Last class, we talked about that capillary fringe, that tendency for water to kind of move up right at the water table there. Well, that's because water is sticky. It pulls the other water molecules along because of that polar nature, that attraction to the different charges. It allows water to move through really tiny spaces, okay? Even against gravity, okay? If I put a paper towel in water, the water is going to move up that paper towel. It's called wicking, and it's because of capillary action, okay? We also get something known as surface tension, and this is the tightness of water at the surface, okay? This is why a belly flop hurts. This is why small animals, small bugs can walk on water. You need to break that tension between the water molecules. They stick to each other, again, because of that charge. And that's a surface thing. You can see this picture right here. That's a penny with multiple drops of water on it. The water at the surface is holding on to the other molecules, and it allows it to make this kind of bubble that almost looks like it's defying gravity, okay? Another feature of water is that it's very easy to dissolve things in water. Water is known as the universal solvent. It dissolves multiple things. And a solvent is just something that dissolves other substances. Okay, you can dissolve salt in water. You can dissolve sugar in water. You can dissolve a lot of things in water. You can't mix water and oil, though. That's because oil is a non-polar substance, but that's not what we're talking about. Okay, so water also has a tendency to have a lot of minerals in it. Okay, as the water is percolating through the soil, it picks up minerals out of the ground. Okay, and so that groundwater always has dissolved minerals in it. We talk about the amount of those minerals as the water's hardness. The harder the water, it's still liquid, but the harder the water, the more minerals are in that. And you probably have noticed this around your homes. Okay. So hard water doesn't suds up quite as much. If you're taking a shower and you have hard water at your house, you don't get quite as many suds with the shampoo, and you get a lot of these mineral deposits on faucets and water spots. If you put a glass out on the counter to dry, it'll leave water spots behind. Okay, it's drinkable, but it has lots of minerals in it, and when the water dries, when the water evaporates, it leaves those minerals behind. Okay, scale is another name for those mineral deposits that get left behind. Soft water, it's no more liquid. It just means that there's less minerals in it. Okay, now with soft water, you get a lot more suds, and so if you have soft water at your house, you don't actually need to use as much soap because it suds up more. If you have hard water, you can use a water softener to soften up the water. And what it does is it just pulls some of those minerals out. And there's different ways that it does that. We're not going to get into that, but that's what a water softener does, is it removes some of those minerals. Okay. So what do we need water for? Aside from like life, okay, there's different kind of categories of how we use water. This blew me away right here. Americans on average, and this is a figure back from 2013. This is when some statistics were put together. Back in 2013, the average daily use of water for Americans was 4,300 liters of water a day. That's a lot of water. Okay, so if you could picture a 2 liter soda bottle, because liters are metric, we kind of talk about gallons, but you're familiar with 2 liter bottles. So that would be 2,150 2 liter bottles of water a day. Okay, crazy. Agriculture is actually the biggest use of water. Okay, it takes a lot of water to do farming, but it takes a lot of water to raise livestock as well. So whether it's farming or livestock, that's considered agriculture. Lots of water. Okay, irrigation is what's necessary to water the crops. Okay, so these farms are oftentimes built and grown in somewhat dry areas. They don't have natural sources of water, so you need kind of like a really long garden hose, and so you've got pipes and all this stuff, and it brings water in. Okay, lots of water. You can see about 70% of the total water usage goes to agriculture. Industry is another big one. All these factories, we talked about like the hydroelectric dams and turbines in the last chapter. A lot of those turbines are turned with the use of steam. Okay, so in industry, water is frequently used to cool machinery as it's moving, or the water's heated up and that produces steam, and then that gets machinery to move. Okay. Water is also used for transportation. Cargo ships, when you order things on Amazon, a lot of times it's coming from other countries, and so it needs to get shipped here. People can use water as transportation. There's ferries and things like that to transport goods and people. And recreation. Who doesn't like to go to the beach, or a lake? Okay, we like to swim and go boating and fishing and things like that. So those are common uses of water. This is besides household use. Okay, we also use water in our homes, but it's actually a pretty small percentage of all the water usage. Okay, here's how we use water at home. Okay, this chart right here kind of shows that again, on average, a person uses about 120 gallons a day of water, and this breaks down the different ways we use it. Okay, most of it is actually outside to water our yards and things like that, but like 13 gallons of water to shower, that's a ton. 14 gallons of flushing toilets. Okay, so we need to be able to save this. We need to be able to conserve water because it is a renewable resource, but we need to be responsible with it. We might be in a drought, and water costs money. Okay, so one of the main ways to conserve water is to reduce our usage. If a toilet is running, fix it. If there's a leak, fix it. Okay. New fixtures, so like faucets and toilets, are actually made to use less water. That's a way to conserve. Don't run the washing machine or the dishwasher unless they're full. Washing 2 shirts uses the same amount of water as washing a full load of laundry. Take shorter showers. I know it's hard. It's nice to stand in that nice warm water, especially if you take morning showers. But if you could cut just a few minutes off the shower, you're saving water because that water is just running down the pipes. And when you brush your teeth, make sure you turn the faucet off while you're brushing your teeth. Okay, you can get your toothbrush wet, but then turn it off and then brush, and then wait to turn it back on until you rinse. Water can also be reused. Okay, now a lot of our household uses, we're not going to reuse that, but there are things known as dry wells, and so if, let's say you took a shower, or let's say you washed your clothes or dishes or something, some places will actually collect that water. It's known as gray water. It's not sewage. We'll collect it, and then that can be used to water like landscape and stuff. Okay. Little things like parking your car in your grass and then washing your car on that, and so the water is actually watering the lawn. So just a couple of kind of simple ways of reusing the water. Right. Now, a big problem is water pollution. Okay, pollution in general is when something is added that causes harm, and it might actually be to the extent to where it's unusable. Okay, air pollution is when something's in the air that damages it. We're talking about water, so water pollution. Something is getting into the water and harming it or making it unusable. Okay, mostly chemicals. Gas, oil, a lot of farming stuff, a lot of agricultural stuff like pesticides and fertilizer. This is why if somebody has an oil leak in their car, they should fix it. Okay, because a lot of that stuff gets into the streets, and then when it rains, all that stuff goes into storm drains, and then it actually flushes it out to the ocean. Okay, so a lot of chemical pollution. Thermal pollution, you might not think of this, but if industries, if factories are using water to cool their machinery, they oftentimes will dump that hot water into the source, which is a river or a stream or a lake or something, and that harms the rest of the kind of habitat there. The higher the temperature of water, the less oxygen there is, and so it's harmful for the animals living there and plants. Okay, so hot water is actually considered pollution. Minerals and sediments can also actually get into the groundwater. Usually when the water kind of seeps through the ground there, it gets collected in these aquifers and it's pretty clean, but sometimes there's still some sediment and there could be too much content of minerals in there, which would be considered pollution. Okay. We also have biological pollutants. That's just bacteria, okay? And that comes from poop, feces, okay? In a lot of areas that don't have easy water sources, they get their drinking water from the same location that they're bathing and washing clothes and all kinds of stuff. And so there's oftentimes a lot of bacteria in the drinking water, and that can obviously cause problems, okay? And then one thing not listed on here is just trash. Okay, you look around and you go to Aero Vista Park and there's always just trash in the water. It's just harmful to the water. It's kind of gross, so clean up after yourself. We can treat water. This is actually sewage water. This is not just like washing machine water. So when you flush the toilet, all of that stuff goes to a treatment plant. Okay, and if you look on where is it? Page 413. It kind of breaks down all the steps. And I listed several of those steps over there, but I want to just kind of talk it through with you a little bit. Okay. So the first thing that happens is this water goes through kind of a big filtration. Okay. And so large pieces of trash, leaves, things like that are removed. Okay. But there's still nasty stuff in it. Okay. So then it goes into a tank and it's called a settling tank. And the big stuff settles down at the bottom. And these chemicals might be added to it that causes something called flocculation, which causes the debris to clump together and sink to the bottom. Okay. And so the water up on the top, or here's the clarifying center, the primary clarification. The gross stuff settles out and might be pumped off, and the cleaner water, it's still not drinkable yet, will go somewhere else. Okay, it's kind of taken off the top. So that's kind of a whole collection of things. You use gravity to settle out the big stuff. You use chemicals to help clump together the big stuff, and then the clarifying tanks kind of help separate those. Okay. Now you might pump that water through a field of bacteria, because the bacteria in this case is actually really good. It helps digest and eat away some of the stuff that's still in the water. Okay. Then it'll go through these aeration tanks, and that adds air bubbles. And what that does is it actually helps get rid of some of the bad smell, and it actually helps make the water taste better. Then it's going to go into another clarification tank, and if there's anything left, it's going to settle out. And then the water that's left is pretty good. It might have to be disinfected, and sometimes chlorine is actually added because that will kill any bad bacteria, like that coliform bacteria from the previous slide, if any of that's left. Now this water's tested. The mineral content has to be within a certain range. The bacteria content, it has to be within a certain range. And if it's clean enough, it can actually be considered drinkable again. Okay. A lot of times what happens with sewage treatment, though, is this water is then used to water like golf courses, or it's just put out into evaporation tanks, and then that evaporation goes back into the water cycle. Okay, so that's it. Bye. Get a glass of water.